Hey everybody, welcome to Unit 12. Just want to let you guys know I am locked inside my bedroom at home. The dog's with me, so if A, you hear somebody chewing on something, that's the bone. The dog's husband. And if you hear kids screaming in the background, that's right. We've got two little girls and they have a friend over, so I'm going to do my best to be louder than all of that. Okay, now we're going to talk about something very simple probability today. Here is the eligible content from the Keystones directly from their website. We're going to work on probabilities today. We might have a couple of compound events, like maybe you're looking for red or blue or twos and fours. I don't know. But today, everything today is going to have one fraction. Okay, so what is theoretical probability? So glad you asked. Theoretical probability is based on the possible outcomes or the potential of something to happen. I'm going to actually, it's likelihood. That's the real thing there. Likelihood. Ooh, likelihood. Don't think there's an E there. If there is an E there, you can yell at me later. Now there is experimental probability. It's based on the basis of the observations of an experiment. We are not going to do this today, but I just wanted to let you kind of know there are two different types. We're going to focus on theoretical, and now it's really bothering me that I might have spelled that wrong. So we are just going to do a quick little look-see. Likelihood. Oh dear, how embarrassing this is. Oh, there was an E in there. Okay, so really sorry about that. Definitely not going to fix my video, so just going to add the E in there. You know what? I'm really good at math. There you go, the likelihood of something happening. All right, so we're going to talk about theoretical probability. That's something you can't change. Like, it's not based off a survey you made. It's not based off of, a test that you run. It's just like, there's two sides to a coin. That's theoretical probability. Or there's 6 sides to a die. That's theoretical probability. Probability is the measure of how likely an event is to occur. Let's see. All the possible outcomes is called the sample set. And let's see, what else do I want to hear? PE is the probability of an event. So, for example, if you have P and then you write the word heads here, that's probably like you're flipping a coin and you're looking like, what's the probability of getting a heads on a coin? Well, it's 1 out of 2. So probability is the number of favorable outcomes, like things that you actually want to happen. And it's a ratio, so you divide. So it's divided by the number of possible outcomes, okay? So that's like, let's say that you are looking for the probability of getting a tails. How many tails are there? 1. Out of how many total sides? 2. And you could make that a percentage. We'll work on that more tomorrow. Today, our simple events, we're just going to look at one thing happening today. You're not going to be like rolling a die and flipping a coin. We're just going to like roll a die. Or in the next one, we might pick a marble, something like that. So let's jump into it. Number 1. A jar contains 32 red marbles. I will conveniently underline that. 28 blue marbles. That's the dog. Okay, now it says, what is the probability that it's going to be red? So you can see this was already set up for you. The probability that it's going to be red. So something that we need to make sure we find is the total amount. So 32 plus 28 is 60. And what are we looking for? How many red are there? There's 32. So the probability is going to be 32 divided by 60, but you have to reduce that. Okay, so let's grab our calculator and turn it on. 32 over 60. If you wanted to change it to a percent, that would be 53.3%. But if we just want to have our calculator help us reduce it, we've always known that math enter is a beautiful button. So that is going to be 8 over 15. There we go. So when I reduce that, that's 8 out of 15. Again, if you want it as a percent, it would be 53.33%. If you multiply this top number here on my calculator by 100, that will change it to a percentage if you're interested in doing that. So we need to definitely be able to make a reduced fraction today. This is the goal today. If you can also change it into a percentage, that's even better. Number 3. A letter in the word restoration, so just a single one, is randomly selected. What is the probability of selecting a vowel? So the total, let's count a letter in the word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 on there. And I'm going to count those again just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I would hate to do this problem and have to undo it. So there are a total of 11 letters. So now they want me to select a vowel. So that's A, E, I, O, and U. So I'm going to count them. Here's E, O, A, I, O. Let's count those. 1, 2, 3, 4, 5. So there are 5 vowels. These are all the vowels that exist, like, in English. But there are 5 of them in our problem. Okay? So I have 5 out of 11. And it says, hint, what are the vowels in the word? It was E, O, A, I, and O. That doesn't reduce. You can check it out on the calculator, but that is not going to reduce. If you really wanted to make it a percentage, you would take the fraction, make it a decimal, multiply by 100. So I'm going to write or 45.45%. Okay? So let's go to number 5. A day in the month of January, so we're focusing on January, is randomly selected. What is the probability that's a prime number? Oh my goodness. Well, first of all, you need to know that January has 1 through 31 in it. So there are 31 total days. You always have to find the total, okay? And I'm not always going to give you that there. You should be able to come up with that on your own. You have to be like, oh, I have to find the total. Now, the prime numbers. I'm just going to ask one by one. 1 is not a prime number. Hopefully you remember that. 2 is a prime number. 3 is a prime number. 4 is not because it can get divided by 2. 5 is a prime number. 6 is not because you can divide it by 2 and 3. 7 is. 8 is not because you can divide it by 4 and 2. 9 is not because you can divide it by 3. 10 is not. 11 is because you can't divide it by anything except 11 and it's 1. This is only factors. 12 is definitely not because we got 3, 4, 2, and 6. 13 is. 14 is not due to 7 and 2. 15 is not because of 5 and 3. 16 is not because of 8 and 2 and 4. 17 is. 18 is not, by the way. Other than 2, there's no more even numbers that are prime. 19 is. 20 is not because of 4 and 5. 21 is not. 22 is not. 21, 7 and 3. That's why. 22 is 2 and 11, so that's not. 23 is. 24, 24 is not because of 4, 6, 3, and 8, 12 and 2. 25 is not because of 5. 26 is not because of 2 and 13. 27 is not because of 9 and 3. 28 is no because of 14 and 2. 29 is yes because it doesn't divide by anything except 1 in itself. 30 is not because it divides by 2. And 31, that is. Nothing goes into 31. Okay, so now that I've listed all the prime numbers, how many do they end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's go back sure I didn't miss any. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So there are 11 prime numbers in the month of January divided by 31 total. And 11 does not divide by 31 evenly, or it doesn't reduce. So if you hit math, enter, enter, notice you get the same thing. If you did want to practice making it a percentage now, you divide it and multiply by 100. Whoops, I'll just multiply by an extra 10. So you get 35.48% if you were to pick a random day in the month of January and see if it was prime or not. Like maybe my mom's birthday, which is the 26th. So that would not be part of my probability. What is the probability of drawing a heart or a club from a standard deck of cards? Now here, I also don't know if everybody knows what a deck of cards has. It has a total of 52. Maybe you know. Let's just make sure you hear it now. There are 13 hearts in a deck, and there are 13 clubs. There are 13 of each suit. So if we're looking for a heart or a club, we add our options together, and there's 26 that are either hearts or, oops, not of, or clubs. My kids are so loud. So it's going to be 26 out of 52, which reduces to 1 out of 2. And I'll just show you that so you can see it over here. So half the deck, in other words, 50%. So if you're looking to get a heart or a club from a standard deck of cards, you would have a 1 out of 2 chance or a 50% chance. Now we're going to talk about this bag of crayons. We have 8 red. I'm a very visual learner, so I like to see them underlined in that color. 14 that are purple. We have some yellow ones. Oh, that's going to be sorry, just burning your eyes there. And green. Okay, so we are going to pick one crayon. We're just going to pick one crayon. Tomorrow we might pick 2. So red or purple. So the word or means we're going to add those together, just like we did in a previous problem, right? Actually, the one right before it. So that's going to be 8 plus 14. So there are going to be 22 there when you add those, you get 22 out of, we didn't find the total yet, did we? Well, let's do 8 plus 14. My kids are so loud. Plus 6 plus 4. Okay, so just so you guys know, there are 32 total. That's going to be important for all of the rest of the problems. So 32. I'm going to choose to reduce that now. I think they both divide by 2, right? Did you guys know that? Oh, they're so loud. And when they have friends over, they're even louder. So that's 11 over 16. If you want to make that a percentage, go ahead. I'm just going to leave it as 11/16 of a shot right now. So now we're going to do green. So all I want is just green, just regular old green, not anything else. So that's going to be 4. So 4 out of 32. Do you guys know that's going to be, do you know? 1 over 8. Feel free to try to reduce on your own. Okay, red or yellow. So the red is 8. The yellow is 6. We're just drawing once, so we're going to add those results together. So it's 14 out of 32, which is going to be 7 over 16. But just in case I'm not thinking straight, there it is. And if you guys want to make those a decimal, that's great. Today, I'm not overwhelmingly concerned about the decimal, the percentage thing, but I'm concerned about, do you know when to add them? And I'm concerned, can you reduce your fraction? Okay, last, I think the last probability example, we're talking about raffle tickets of 1 through 40. So there's a lot of vocab that we're just about to take a look at. Let's just see how we do. What is the probability of, and then we need the notation and the answer. Okay. What is the probability of picking one? So we have 1 through 40. Okay. What is the probability of picking one of the numbers 3, 13, or 23? So I'm looking for probability of getting a 3 or a 13 or a 23. Well, there's only one of each of them. So that's 3 out of 40. Which, if you don't believe me, does not reduce, but I'll show you over here. Okay, so 3 out of 40 is it. That's a probability of getting a 3 or a 13 or a 23. I have unfortunately seen kids add 3, 13, and 23, but you're asking how many 3s are. How many 3s are there? How many 13s? How many 23s? And that's how that's done instead. All right, now, what is the probability of picking a numbers greater than 25 but less than 35? Okay, so greater than 25 would be 26, 27, 28, 29, and what do I have to stay less than 35? 30, 31, 32, 33, and 34. So I need bigger than 25 but less than 35. How many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 chances here. So the probability of picking greater than 25 and less than 35, I just wrote that really in a lazy way here, is a 9 out of 40 chance. Which I do not believe, well, I know it does not reduce. So it just stays 9 out of 40. So not great. Okay, now let's do this. The probability of picking a number ending with 0. So on 1 through 40, 10 ends with 0. 20 ends in 0. 30 ends in 0, and 40 ends in 0. Oops. I guess that's okay. 1, 2, 3, 4. So my probability of picking something that ends with 0 is 4 things that I wrote right here. There's 4 possibilities out of 40 total. So this is what we call favorable. May as well make sure I cover that. Over total. And that is going to be a 1 out of 10 chance. You can use the calculator that I like somehow made disappear when I hit full screen there. Whatever. I go whatever. All right, so 4 out of 40. There you go, is a 1/10. And that'd be 10% if you're interested in trying that, trying the percentage thing. What is the probability of picking the number 7? Well, there is only one number 7. So the probability of picking a 7 is just 1 out of 40. So guys, I'm going to be very honest with you. If you can't do this, you're not going to get full credit. Okay, so you have to be able to write the notation and make the fraction, and if possible, reduce it. In this case, I didn't need to because 1 out of 40 does not reduce. Okay? All right. So Algebra B, you know, it just flows from Algebra 1A. We have to know this kind of stuff. We can't just let this like go out of our brain. This is still a continuation from, it's just one big course. It just so happens that it's all year long. So absolute values give you 2 answers. Remember these? 2f plus 9 is less than or equal to 13, and 2f plus 9 is greater than or equal to negative 13. Remember, flip, flip. This is a less than, so I'm looking for an and. Less than, and, so I'm going to look for an overlap of my answers. Take away 9. 2f, my daughters, less than or equal to 4. Yeah, that's right. Divide by 2. I pulled this straight from the book, and they usually don't give you icky answers. Okay, so there's 1. F is smaller than 2. Now let's solve this one. Minus 9, minus 9. Please be careful on your calculator here. 2f is greater than or equal to negative 22 if you put that in your calculator. Divide by 2, divide by 2. It's not, you're not flipping this sign here because you're not dividing by a negative. I know a lot of kids get stuck. They're like, but my answer is negative. That's okay. You're not dividing by a negative. All right, so let's see. I'll put 0 right here. Okay, I need to get to negative 11, and I need to get to positive 2. I'm just going to count by 2s. So 2, 4, 6, 8. Oh my gosh, I'm so sorry about my children. I literally might pause this video and go yell at them. I'll give them one more chance before I let the wrath come out. All right, so I'm going to look at closed dot. So I'm going to do this one first, okay? So closed dot at 2. And it needs to point to the left because it says less than. All right. And then closed dot at negative 11. I'm going to change colors. And that one's going to point this way. So please remember the final answer, since this was an and problem, is only where the orange and the blue overlapped, which in this case means I need to erase everything outside of those solid dots. Remember, and problems is an overlap. So that answer that I have right there is your only answer. Now we're going to do an or problem, okay? I know it seems like, well, this is dumb. You made me do this last week. I know. But the more you do it, the better you get, and the better chance and really the more comfortable, hopefully, you feel when it comes to the keystone. So the first one we keep, the second one we change. Please notice I flipped the sign and the negative. The first one, we're going to add 7 and then divide by 3. So adding 7 gives us 3D is greater than 35. Ooh. Dividing by 3, yucky, yucky, yucky. Guess Miss Langeli made this problem up. If you get, usually people like freak out when they get decimals. All that means, guys, is that life, like, oh well, like it happens. Life isn't perfect, right? So, but we're going to get a weird decimal of 11.7-ish. I'll write 11.7 just because it's good enough. It's rounded, but that's good enough. That gives me somewhere I can graph. Add 7, 3D, and negative 21 when you add there. Oh, I like this. I can divide by 3 all day here, huh? D is less than negative 7. Don't flip your sign because you didn't divide by negative. Okay, now this started as a greater problem. So we're looking for a or. So it should be anywhere that either line. So I'm just going to write either line exists. We do not need an overlap. All right, so we're going to go to, what do we have? I'm just going to do the same thing. Starting at 0, skipping by 2s. What do I have to get to? I have to get to 12, essentially, right? There it is. And I have to get down to negative 7, so. Those negatives make it tight. Okay, and putting an open dot at 11.7. Open dot, and it said greater, so it's going to point that way. Forever. And what is this one? Open dot at negative 7. And it was less than. And I am not looking for an overlap, so I'm done. Anything on this side is an answer. Anything over here is an answer. Anything here is not an answer. All right, now, I promised you guys I would give you some special cases, and here they are. All right? It is super important that you follow along. Just stick with me. I know, like, my voice is probably droning on at this point, but it's important. 5m minus 9 is less than or equal to negative 24. Notice this is an and problem because it was less than, so we're going to have to look for an overlap. And 5m minus 9 is greater than or equal to positive 24. So I flipped and I flipped. Let's solve. You guys are good at solving these, right? As long as you like type them in right in your calculator, you know, use that. So we get 5m less than or equal to negative 24 plus 9 is negative 15. Divide by 5. M is less than or equal to negative 3. Now we're going to look for this one over here. And we're going to, again, we're both aligned. The word and means, oh, sorry, I kicked the dog in the face. Where both lines exist, okay? So add 9. 5m greater than or equal to, what is that going to be, guys? 33. Divide by 5. Boom, 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 boom. Hey, if I'm solving faster than you can solve, can you please pause the video and try to do it on your own, okay? No point in me. I can't solve. I'd love to, but I can't do your keystones for you. All right, so I'm going to do 0. I can count by 1s. There we go. 7. And I can count by 1s. I have enough room. Come on, Amy. Fit it on there. Eek. Okay. Okay, close dot at negative 3, right? So close dot, and it's got to point this way. And over here, close dot, and it's got to point this way. So this, remember, was supposed to be an overlapping problem. There is no overlap, which means there is no solution to this problem. All right, no solution because there's no overlap. There had to be an overlap because it was an and problem. It was an and problem because it had less than. And here's why, guys. Ready? At the very beginning, absolute values cannot be smaller or less than a negative number. And then that's it. That's the reason. All right, take a look at this one. This is going to be an or problem. So it's where either line exists. So y plus 8 is greater than or equal to negative 3, and y plus 8 is less than or equal to positive 3. Okay, you learned this with Miss Miles and Mr. Thomas. Take away 8, take away 8. Y is greater than or equal to negative 11. Take away 8, take away 8. Y is less than or equal to negative 5. I'm going to have to count by 2s. 0, 2, 4, 6, 8, 10, 12. And, oh, silly me, they were all negative, weren't they? Well, that's embarrassing. Oh, well, that's fine. I'll figure it out. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. Hopefully that's enough. Yeah. Okay, so I'm going to do this one first, okay? So it's got to be greater than or equal to negative 11. So that's like right here. There's negative 11. And there is greater than or equal to negative 11. And less than or equal to negative 5. Well, here's negative 5. And less than or equal to that goes this way. Now this is interesting. Because this is an OR problem, see how it covers the whole number line? This is all real solutions. I wish I could guarantee you. So, okay, wait. It's all real solutions because it covers the whole number line. We only cared about where either line exists because it was an OR problem. It was an OR problem because it was greater than, and here's why. Absolute values will always be greater than a negative. Always, always, always be greater than a negative. That's like the rule of absolute values. So, there are two special types, right? There are all real solutions if it was an OR problem being greater than a negative, or it's no solutions if it's an AND problem and it's smaller than a negative. There are some other special ones we'll get to at some point in time, but just not today. And then just taking your mind back to probability, I love to write my options out so that I can make the numerator of my fraction. Sometimes kids are like, well, I'm just going to guess that there's this many prime numbers or this or that. Don't do that, okay? Just do it the right way. Write them out. And probability, simple probability today, that was the main takeaway. The new stuff for today, along with the review, was it's how many are for you versus how many total. And that is the end of the lesson.